Welcome back. So in this video, I'm going to discuss about the X.509 certificates. What do you mean by the standard? What are the different things that are present in X.509? Simply put, an X.509 certificate is a widely used digital certificate format based on the principles of asymmetric cryptography and also an interface description language ideal called as abstract syntax notation. If you are wondering what do you mean by ASL.1, it is a standard for the specification of abstract data types. Simply put, it is a way to which is going to tell you how do you send information across the telecommunication protocols, irrespective of the syntax or irrespective of the application that you use. So, if you are wondering where does this X.509 certificates fit in the whole concept of cryptography, they do play a very crucial role. These are the standard ones which are issued for each browser for almost different types of applications that we shall discuss later on. X.509 certificates are also often used to verify the sites and servers based on the Internet Engineering Task Force standards, so IETF standards. These certificates are generated and managed by a type of infrastructure called as PKI. In other words, we call it as public key infrastructure. These X.509 play a crucial role in this entire infrastructure on verification of the different websites and servers identity. We learned earlier that distribution of public keys do play a very crucial role for the success of public key cryptography. We need to have a secure way of exchanging the public keys and also the users authenticating themselves. Or we need to have some sort of confidential thing that this particular certificate belongs to a particular user. X.509 does exactly that. For this purpose, you can see that we have a new entity called as certificate authority. So X.509 certificate binds a name to a public key value. The role of the certificate is to associate a public key with the identity contained in the X.509 certificate. See, to understand, this is how usually a certificate looks like. You can see, let us say that Bob wants to apply for a certificate. He will be sending his ID information, his public key information to a trusted third party called as certificate authority. This is what. Now, what does the certificate authority do? It will verify the identity. It will see whether the public key is associated to Bob or not. And after that, it will create this certificate, including these two information, your ID and your public key, along with the CS information, who is issuing this certificate, and then it will calculate a hash of all this information. A hashing algorithm is used here, which will calculate or which is calculated across these three values, and this hash is encrypted using, this is the private key of the certificate authority. This is the private key of the certificate authority, and using this private key, the certificate authority will encrypt this hash and attach this signature to the certificate. The reason why we are attaching this signature here, this component here, is to ensure that no other entity or no other entity other than the certificate authority can create such certificates. Because if I issue a certificate, the other person should be able to, or should be confident enough to trust this certificate, isn't it? So that is the reason these certificates can only be created by the certificate authority. Hence, the hash of all this information is encrypted using the private key of the certificate authority. Okay. You can see here, to prevent impersonation, all certificates must be signed by a certification authority. A CA is a trusted node that confirms the integrity of the public key value in a certificate. Now, what happens on the other side? Now, Bob gets this certificate. Let us say that this is the certificate of Bob. We issued it. The certificate authority has issued this certificate. Now he has it. What does he do? For any entity that wishes to exchange or that wishes to communicate with Bob, Bob can simply issue this certificate to that entity. How does that entity verify the authenticity of this certificate? What it will do is, it will once again calculate the hash of this certificate till these three values. It will calculate that hash because the public key of the certificate authority is known to everyone. The public key of the certificate authority is known to everyone.
anyone can decrypt this particular signature, and then it will compare these two hash values. The hash value that your receiver is calculating on the information, and the hash value that the receiver gets by decrypting the signature in the certificate. Now let us assume that if someone has changed, has altered the contents of the certificate, these two hash values will not be the same. Hence, your receiver will reject the certificate. It will not accept the validity of the certificate. That is the reason. Because the certificate can only be created by the certificate authority using its private key. So this is how it works. Let me show you what are the contents that are present in an X.509 certificate. You can see it here. It starts with version. An X.509 certificate contains information about the identity to which the certificate is issued and the identity that issued it. That means it contains two things. The first thing is, to whom does this certificate belong to? And the second thing is, who issued this certificate? Just very much similar to how your degree certificate looks like. That's that if you are earning a BTech degree or a BSc degree, your certificate is going to tell you the information that to whom this certificate is issued, like you, and who issued you this certificate, which university has been issuing this certificate. Like that, similarly, the X.509 certificate contains the information of the certificate owner and also the certificate issuer. So these are the fields that are present in this particular one. The first one is the version. It actually differentiates among successive versions of the certificate format. By default, it is 1, and currently the version is 3. So, but almost all the latest certificates do follow the version 3 format. We will discuss about what is the difference between version 1, version 2, and version 3. This is the first one, version, right? The second one is we call as a serial number. This is an integer value unique within the issuing CA. That is unambiguously associated with the certificate. That means a serial number is unique and issued to only one certificate in one certificate authority. Like just like your roll numbers, which is unique to you, a university will be issuing a certificate to only one roll number or to one person. So to uniquely identify you, I will directly type in the roll number. Similarly, a certificate is uniquely identified by the serial number. This is unique within one CA. Now the next field in the X.509 is signature algorithm identifier. You can see here. There are two parts here. What is the algorithm and what are the parameters that are associated to be used with this algorithm? So this signature algorithm, the issuer uses to sign the certificate. You know that there is a signature that is attached to the certificate, isn't it? So how does this signature is generated? So how is the signature generated by the authority? Which algorithm has been used to create this signature is written over here. So this is the field which tells you what the signature algorithm identifier, which algorithm has been used, and if there are any parameters that are associated for generation of this signature, all those parameters are also added here. Next one, you can easily understand who is the person or who is the authority that is issuing the certificate. The names are of the X.500 directory, the name of the entity issuing the certificate, which is usually the certificate authority's name. The next field is the period of validity field. Once again, it consists of two things. The first one is not before and the second one is not after. The first date till the last date for which this certificate is valid. Now you might be questioning, what happens if this date passes? The certificate will become invalid and it will be rejected. So any issuer or any user will have to apply for the certificate extension. We will discuss this in the next video. How do you extend these certificates? What do you mean by certificate revocation? Or what do you mean by a certificate revocation list? So the next one is the subject name. The subject name is nothing but the name of the user to whom this certificate refers to. That is, the certificate certifies the public key of the subject who holds the corresponding private key. To whom this particular certificate is being issued is written over here. So this is the owner of the certificate, or this certificate is going to tell you that this particular public key belongs to this. So my name is, let us say that Mukesh. If the subject's name written is here Mukesh, then automatically this certificate is going to confirm that the public key which is over here, it belongs to Mukesh and the corresponding private key belongs to Mukesh. That is what a certificate does. Issuer name is nothing but maybe if you take University Jain Kakinada or Siddhartha University, like that, whatever whoever authority that is issuing the certificate. Let me go to the next fields. The next field is the subject's public key information. This is what the certificate is designed for, isn't it? The public key of the subject plus an identifier of the algorithm for which this key is to be used together with any associated parameters. That means this public key can be used for different algorithms. Let me put in an easier manner. Now, if I'm issuing the certificate for it to be used as an for RSA encryption, or I can use it for Diffie-Hellman, or I can use it for L-Gamma scheme. So my public key can have multiple usages. So if I want to specify for which algorithm this public key is to be used, and if there are any parameters that are to be used along with this public key, all that information is present over here. You can see subject's public key info, the algorithms that it can be used, what are the parameters that are associated with this particular key, and finally, what is the key value. So these are the three fields that are present in the subject's public key information. So this is my name and this is my public key. This are the first ones which we gave out in 1988. That is what we call as X.509 version 1. Later on, two other fields were added in version 2, which we call as issuer's unique identifier, an optional bit string used to identify uniquely the issuing CA in the event the X.500 name has been reused for different entities. Just like that, if I have multiple certificate authorities that might have the same name, then in that case, this field is used. That is the reason we say it is an optional one. That is the reason this field is used to uniquely identify the name of the certifying authority for which this certificate is issued from. Right? Similarly, the next field is also going to tell you in case the subject name is not unique here. If I want to specify the uniquely the subject's name for which this certificate is issued, this field is used. These are the two fields that were added in version 2. These two fields are very rarely used. They're not used that much. They are just in case which are used only to provide an unambiguous answer to the question, the uniqueness of issuer and the uniqueness of the subject name. And then comes the extensions. There are a lot of extensions which are added in version 3. Not all the extensions are being used every day for every certificate. There are multiple extensions which we will discuss in another video. The purpose of adding these extensions is for the means to provide extra information about the certificate, for which the certificate is to be used, for which it cannot be used, all that additional information, key information, policy information, subject information, all those extra additional information that we can add are added over here. These extensions are part of version 3. And the last part, this is all the information. And the last block here is the signature block. You can see that the signature block covers all of the other fields of the certificate. It contains the hash code of the other fields. So if I take a hash from here till the last one which is added here, if I take a hash and then take the hash value, encrypt it using the private key of the certificate authority, then I get the signature. So this has my certificate values and then the encrypted hash or the signature of the CA. This is added to the one. So any recipient who has the public key of the CA can now easily decrypt this particular signature, and then they can verify the validity of the certificate. That means unless until I know the CA's public key, I will not be able to decrypt the signature and then check the authenticity of the certificate. So usually the common notation for writing up these certificates is like this. The standard uses the following notation to define a certificate. You can see this. This is the subject's name. This is the certificate authority's name. So this notation, where like if you write it like this tells you that the certificate belongs to X, which is issued by Y. Please remember this because we will be discussing about forward certificates and reverse certificates in the next video. These are the notations which you need to understand. You have to understand there is a chain of certificates that are being used later on. So if I write like this, let me put it in this way also. If I write a notation like this, you have to understand that this is the subject entity which is inside these braces, and this is the certificate authority. The certificate of B issued by A. And you can see that if I write it like this, the signing of I by Y. Now you can see this. That means that all these values, I'm going to take a hash and then perform a sign on it. That means I'm going to encrypt it using my private key or use some other signature generation algorithm. All the values are used for the signature. So V stands for version of the certificate, SN stands for serial number of the certificate, AI stands for identifier of the algorithm used to sign the certificate. This is the algorithm used by the certificate authority. Remember that to create the signature. So which algorithm I'm using, whether I'm using RSA, whether I'm using some ECC, or whether I'm using some other scheme like DSA, all those things are covered here. CA is the name of the certificate authority. UCA, once again, is the optional one. Unique identifier of the CA. UCA and UA are the two fields which are added in version 2. A stands for the name of the user. AP is nothing but the public key of the user. And TA is the period of validity of the certificate. So all these fields put together, if I'm going to create a hash, encrypt it using the private key of the certificate authority, then you have these particular notations. To have a better understanding, I'll show you a small example in Chrome where you can verify how these certificates or whether these fields are present in the modern day as web usage or not. And the CA signs the certificate with its private key. If the corresponding public key is known to a user, then that user can verify that a certificate signed by the CA is valid or not. So if I know the public key, I can simply decrypt the signature. Once I decrypt the signature, I will be able to verify the contents are genuine or not, or whether this certificate has been tampered with or not. So let me show you the example where we can identify these fields are being used or not. Okay.
Now, as I said, as I wanted to show you how the certificate X.509 certificate values would look like. Just open google.com in Chrome. You can see a small button over here. Go over there, click on it. You can see it's the connection is secure. So click on that, and you can see small note that certificate is valid. So click on that, and you can see this is the general details of the certificate viewer. So what's the common name? What is the organization unit? Issued by who issued this, validity period. But as we discussed, what are the fields that are present in X.509 in a particular order, isn't it? If you want to check out that order, go here to the details, and then you can see that. See, this is the hierarchy, which, as I said, we will discuss it later on. What is the root CA, and what are if there are any other CAs through which the certificate has been issued, and these are the fields. You can see in this first field version. Version is version 3. This is the serial number, which we discussed that it should be unique within a given CA, and this is the certificate signature algorithm, and this stands for public key cryptographic standards. The PKCS stands for public key cryptographic standards, which uses SHA-256 with RSA encryption. Basically, these standards provide a standard means of operation which utilizes the cryptographic algorithms or in general public key algorithms. And who is the issuer? You can see this is Google Trust Services LLC, and the country is USA, and the validity of the certificate not before 26/2/24. The validity is still 25/24. That is still May 20th. And who is the subject? Google.com. This is the public key information. It says to which this public key is to be used is elliptic curve public key, and this is the public key of Google. And all these are extensions which will be added in X.509 version 3. This will give you an additional information. Certificate key usage, critical for signing usage, extended key. It's not critical whether you use this or not. It is not a certification authority. Key ID, authority key ID, authority information access. There are a lot of options that are actually extensions that are added as part of your X.509 version 3. So I hope you understood the importance of X.509 now. Unless until the valid X.509 certificate is present, your browser will not open any website. So with that, hopefully you do understand what are all these things. You can just browse through the internet for other information regarding X.509 also. Thank you very much, and do watch the next video.
for the points where how does the subject apply for X.509, how does the subject receive the certificates, what do you mean by forward and reverse certificates, and also what do you mean by revocation of certificates under X.509. Thank you and good luck.